Good morning, students. Today we'll go in detail about the trigonometry which we were discussing yesterday. So now we'll see how with these identities which we were discussing yesterday, that is sine square theta plus cos square theta is equal to 1 plus tan square theta is equal to sec square theta, 1 plus cot square theta is equal to cosec square theta. Okay, so we'll now solve numericals based on these identities. Let us see how these identities are applied in the numericals. For example, now I will prove 10 numericals today. We'll prove 10 numericals based on the proving concept, like that is we have to prove that is LHS is equal to RHS. Now LHS is given in one numerical, that is cosec theta minus cot theta whole square is equal to 1 minus cos theta upon 1 plus cos theta. Okay, now see what is given. We have need to prove this. So we will first take RHS. What we are taking? RHS. So now what they have given is 1 minus cos theta and 1 plus cos theta. How will we will to move further? I think first step is let us rationalize it. Okay. So when we rationalize, how we do rationalize? Here sign will change. Here sign will change. Now you can see 1 minus cos theta into 1 minus cos theta. That is a minus b into a minus b will be 1 minus cos theta into 1 minus cos theta. We'll put same here. But below 1 plus cos theta, 1 minus cos theta. A plus b into a minus b. We are using identity. A plus b into a minus b. So what will this identity? A square minus b square. This identity we have studied earlier. So now here we will write 1 minus cos square theta, because here a is 1 and cos b is cos theta. Okay. Now 1 minus cos theta, 1 minus cos theta. Okay. So now again I can write this 1 minus cos theta, 1 plus cos theta. Okay. But I think going to that step, what we can do is just leave it this. Here I think we can write, now what is 1 minus cos square theta? By using this identity. I am using this identity now. Sin square theta plus cos square theta is equal to 1. Okay. Now 1 minus cos square theta is equal to sin square theta. So I can write here sin square theta is equal to 1 minus cos square theta. So I will write here sin square theta. Okay. So I can write that sin square theta. Now this is what they have given is 1 minus cos theta into 1 minus cos theta. So I can write 1 minus cos theta whole square upon sin square theta. Okay. So this is what they have given. We can take. Okay. So now we have solved this. 1 minus cos theta whole square upon sin square theta. Now we can't do further because it is in the simplified form. Now let us take LHS. In some numericals, of proving LHS is equal to RHS, in some cases we solve RHS and we get the LHS, and in some cases we solve the LHS, we got the RHS. But in this case we have to solve both. That is LHS. Now what is LHS? Is given cosec theta minus cot theta whole square. What we can do, we can we have to convert them in sin and cos form. So what is cosec theta? 1 upon sin theta, cot theta, cos theta upon sin theta. whole square. So now what we can do? 1 minus cos theta taking LCM upon sin theta whole square. So what I got? 1 minus cos theta whole square upon sin square theta. Because squares applies on both numerator and denominator. So we can see we got the answer LHS is equal to RHS. So that is how we can prove. So this is the first question we have proved, that is LHS is equal to RHS. Hence proved. Okay. So this is how we can prove. Okay. So what we have used, only single identity I have used in that case. Sin square theta plus cos square theta is equal to 1. So whichever identity we will use, we need to write while solving this numerical. Okay. I hope it's clear now. We'll move to the next numerical. Okay. Now we'll do it. Take it second numerical. What they have given in LHS and RHS. Okay. So this is the first question I have solved. We'll solve more so that we are able to clarify our doubts. It's very, very important. So in second case, what they have given is LHS. They have given cos A upon 1 plus sin A plus 1 plus sin A upon cos. Now see, this is LHS. Okay, this is LHS. Now RHS they have given 2 circles. It's already clear from this question that in this only LHS we can simplify. We can further solve it. RHS is already in the simplified form. Okay, so now take LHS. What they have given? Cos A upon 1 plus sin A plus 1 plus sin A cos. Okay. How we can solve this? Just take the LCM. 1 plus sin A into cos A. By taking the LCM and we divide this, we got cos A into cos A. Cos square A plus, when we divide this by cos A, we got 1 plus sin A. 1 plus sin A into 1 plus sin A. 1 plus sin A whole square. Simply we have taken the LCM. We are in a very simple form. Okay. Now we'll take it further. Cos square A. What we can do? A plus B ka whole square here we need to apply. That is, what is this? A is 1. A square plus B square plus 2AB. Okay. We have done it in a very simple way. I can write here also A plus B ka whole square, A square plus B square plus 2AB. These identities we have already learned, we have studied in earlier classes, in polynomial chapter in 9th class. Okay, so it's easier for us to remember. Now, what we can take? See, sin square theta plus cos square theta. That is 1 plus 1 plus 2 sin A upon 1 plus sin A cos. Okay. Now, in next step, 1 plus 1 is 2 plus 2 sin A upon 1 plus sin A into cos A. So, what we can do? We can take 2 further common. 1 plus sin A upon 1 plus sin A cos. What will happen? Reduce it. We got 2 upon cos A. Now 1 upon cos A is equal to sec A. 2 into sec A. Okay, so that is how we got our answer. We have proved it. That is this. is equal to RHS, hence proved. Okay, this is how we able to apply these identities. Okay, so we have done two numericals. Now let's go to third one. So now here it is, the third numerical. We'll sort it out, and the third numerical we will take first, that is 1 plus sec A upon sec A is equal to sin square A 1 minus cos A. Okay, that is we need to prove. That is given in LHS and RHS. Okay, so this is LHS and that is RHS. Now let us solve with first LHS. That is 1 plus sec A, sec A. Okay, what we can do? 1 plus sec A upon sec A. That is a question they have already given in that case. Okay, so what we can do? Take one, we can write sec A is equal to 1 upon cos A. Okay, here also I can write 1 upon cos A. Now taking the LCM, 1 plus cos A upon cos A upon 1 plus upon cos. What we can do? 1 plus cos A upon cos A. Take this upside, upper, so you got cos A upon 1. Here it is reduced, I got 1 plus cos A. So this is what I have solved is about LHS. Now let's go to RHS, because in some cases we need to solve both LHS and RHS so that we get the equal, get the both equally. Like now what they have given in RHS, they have given like this. Now what is sin square A? If I see this from identity, I take cos square A that side, so it will be 1 minus cos square. So 1 minus cos square A upon 1 minus cos. Okay, so now 1 minus cos square A, what can I do? How can I write? 1 minus cos square, that is A square minus B square. So I can write 1 minus cos A into 1 plus cos. Okay, so that is what it is. Now 1 minus cos A. Because I have used identity which we have learned previously in earlier classes, 1 minus cos square, that is A square minus B square. Here I can write also A square minus B square is equal to A minus B into A plus B. Done. So now I have used this identity. So finally what I got? Plus cos A in LHS. So finally I am able to get my answer. That is what my answer? That is LHS is equal to RHS. So therefore I can write LHS is equal to RHS. Hence proved. I hope it is clear to all of you and you able to connect with me. That is how these identities are used in the numerical, how the numerical is asked to solve. So these are the type of questions we are doing. So we have done 3 numericals. Now we'll move to the 4th numerical. So 4th numerical is, let's see what they have given so that we can sort it out. These numericals are very simple. This topic is very simple. Just we need to practice more and see how these identities we can use. Apart from this, we can use tricks also so that we can easily solve this. Okay. Now let us take one more example now. They have given in LHS 1 plus sin A upon 1 minus sin A. And what is it? RHS? Sec A plus tan. Okay. So they have given this. Okay, let us solve LHS first. What they have given? in the root form 1 plus sine A, 1 minus sine A in the under root form. Now what we can do, just rationalize it, which we have done in earlier numerical also. In such type of questions we have to see, we have to do rationalize how they have done. Okay. Now A plus B into A plus B. What will happen? 1 plus sine A whole square upon A plus B into A minus B. Okay. A plus B into A minus 1 minus sine square. Okay. Now I can cancel root from here. So I got, okay, we'll solve it further. You can see. Now 1 minus sine square. If I take sine square to this side, what will be left with cos square? So I will get cos square. That is what I have given in the root. Now what can I do is, what we can do is, now we can easily reduce with the square root. So what will happen? I'll got this 1 plus sine A upon cos A. So now I can add them separately. So what I got? 1 upon cos A is equal to sec A plus tan. See, just we have solved LHS and I got RHS and hence. So we have solved 4 numericals here. I hope now it is becoming clear to all of you that how we can solve such type of questions using these identities. Okay, we have solved 4 questions. Let us solve further. Now we will move to the 5th numerical. We have solved 4 numericals. Now we will move to the 5th one. So now 5th one. What is they have given in 5th one is, okay, in LHS side they have given sin theta minus 2 sin cube theta upon 2 cos cube theta minus cos theta, and on RHS side what they have given? Tan theta. So that means we have to solve here by seeing that only we have to solve LHS. Let us see how we can do it. No, very simple. LHS they have given sin theta minus 2 sin cube theta upon 2 cos cube theta minus cos theta. Okay. By seeing it very clearly that it is given, from here I can take sin theta common. So I got this. Okay. And from here I can take cos theta. So 2 cos square theta minus 1. Okay. So now what we can do is, now I can 1 minus 2 sin square theta is there. Okay. Now here is 2 cos square theta minus 1. Okay. So what we can do, now sin upon cos is tan theta. Okay. Now what to do is, now very easy form, let's go to the denominator. What we can do? 2 cos square theta. Instead of cos square theta, I can write here, take this side, this sin square theta on RHS. So what we will get? 1 minus sin square theta. Okay, minus 1. So now tan theta is there. Now 1 minus 2 sin square theta upon, now multiply here, okay, with 2 minus 2 sin square theta minus 1. So I have used her identity, that is sin square theta plus cos square theta is equal to 1, and what will be cos square theta? 1 minus sin square theta. So whichever identity we use, we need to write here. Okay. Now what you got? 1 minus 2 sin square theta. Here you got 2 minus 1, 1, 1 minus minus 2 sin square theta. Okay. So what you got? Reduce it. You got tan theta. That is the RHS side. Okay. So this is called RHS. Hence proved. So we have solved 5 numericals. Okay. Now the next one is next numerical we'll solve. Very easy numericals they are. Just we need to practice more and more in case so that we able to clarify how these identities are useful to us. Okay. So now let us solve one more numerical. 6th numerical. That is sin A plus cosec A whole square plus cos A plus sec A whole square. This is given in the LHS side, and now on RHS side is what they have given is 7 plus tan square A plus cot square. Okay, so both they have given. What we can do is let us solve first LHS side. Okay, sin A, well, right here LHS. So what I got? Sin A plus cosec A whole square plus cos A plus sec A whole square. What we can do is just open this by using formula A plus B whole square. What is A square plus B square plus 2AB. Okay. Here also A plus B whole square, that is A square plus B square plus 2AB. Now you can see sin square A plus cos square A. 1. And now what we can write? What is cosec square A is? 1 plus cot square. Okay. Plus. What is sec square A? 1 plus tan square. Okay. So I am just using the identities here. Now when I use the identities, we'll move further. Now these identities have been used. Now further we can see 2 sin into cosec A. So here I can write cosec A is equal to 1 upon sin A plus similarly 2 cos A into what is sec A, I can write 1 upon cos A. Okay. What I can write is 1 upon cos A. So this will be reduced. Now you can see 1 plus 1 2, 2 plus 1 3, 3 plus 2 5, 5 plus 2 7. So I got 7 plus cot square A plus tan square is equal to RHS. So just I am using these identities, we can easily simplify such kind of numericals. Okay, so this is, we can say, hence proved. Okay, so here we have solved 6 numericals. Now we'll move to 7th one. Let's see how we can solve the 7th. Now what is, we have solved here 6 numericals. Now we'll solve the 7th numerical. Let us see how we can do it. On LHS side they have given cosec A minus sin A into sec A minus cos A. Okay. On RHS side what they have given is 1 upon tan A plus cot A. Okay. So we have to solve both. So let us see how we can sort it out on this. Now, what they have given in LHS side first. Cosec A minus sin A. Sec A minus cos A. Okay. what we can do is, right, cosec A, we can write 1 upon sine A, okay, minus sine A. Now sec A is 1 upon cos A minus cos A. Okay. What we can do further? We can take LCM now. Okay. So here I will write sine A. Here I will write 1 minus sine square into, here also I can write this. Okay. So what is, we can do like this. Now what is 1 minus sine square? If I take sine square there, I got cos square. So you can write cos square A upon sine into. Now 1 minus cos square A. If I take cos square A there, what will happen? What will be left? Sine square. So I got sine square upon cos A. So I got this. So I can reduce here sine 1 cos A. So I got sine A into cos A. Okay. So that is how we can solve this. Now here both will be solved. We have solved LHS. Now we'll solve RHS. RHS is 1 upon tan A plus cot A. Cot A. Now what we can do here? We write here, okay, tan A will be sin A upon cos A plus cos A upon sin A. Okay. Formula is there. We can write sin tan is equal to sin A upon cos A and cot A is equal to cos upon sin, because cot is the reciprocal of tan. So now what we can do here? Take LCM. Sin A cos A. Now by taking LCM I got this. Now we all know sin square A plus cos square is equal to 1. So I got this. Sin A cos A. Okay. So now it will be taken upon side. So we got sin A cos A, which we have proved here also. Okay. So we finally got LHS is equal to RHS, hence proved. Okay. So you can say easily, hence proved. So now that is how we able to solve such type of numericals. Okay. So we have solved 7 numericals out of 10. So now let us solve more numericals. Okay. We have solved 7, left with 3 numericals. Today we will discuss only about this 10 numericals today, and later we will study more about other topics also. I hope it will be clear to all of you after after practicing such kind of numericals. Okay. Now I am on 8 numerical. Okay. Now what they have given is, so they have given 3 sides. 1 plus tan square A upon 1 plus cot square A. Okay. What they have given. Now we need to prove 1 minus tan A upon 1 minus cot A. Okay. That is they have given. So we need to prove this tan square. Okay. So we all know that we need to prove this both equally by tan square. Good. So they have given like this. Now how to prove? Let us take this first. 1 plus tan square A upon 1 plus cot square A. By seeing such identity, we can easily identify that is 1 plus tan square is sec square. Okay. 1 plus cot square is cosec square. Now we know that is 1 upon cosec square A is the reciprocal of sin square and 1 sec square is reciprocal is of cos square. 1 upon cos square will be, you can write easy. So what I got? Tan square. So here I have proved this equal to tan square, but I need to prove this also. How? See, what they have given is an RHS 1 minus tan A upon 1 minus cot A. Okay, so this is what. Now what we can do is, let's try to solve this. How to solve this? Now write sin A upon cos. Okay, we can write tan A is equal to 1 upon sin A upon cos A, and cot A I can write cos A upon sin A. Okay, this is given in the square form. Okay. Okay, so now we can solve it out like take LCM of that. So cos A minus sin A upon cos A upon, when take LCM, sin A minus cos A upon sin A whole square is equal to, what we can do is take L minus sign common from here. So sin A minus cos A upon cos A into sin A upon sin A minus cos A. Okay, so now this is, we have taken, so square. Now this can be reduced. Now sin upon cos A is a tan A, minus sin is there, so we can write tan square is equal to RHS. So we see how we can finally do it. Okay. So what they have given us. So now we'll move to the next numerical. I hope it's clear to all of you. Now we'll move to the next numerical. We have left with only 2 numericals. So we have already solved 8 numericals. Okay. So now what you can do is just let us solve more. Now we have solved very easy numericals, but now we'll solve for the numericals. Like what they have given is, we need to solve 2 more numericals now. Okay. Now let us take this numerical. Sorry, is it 9th numerical? Cos A minus sin A plus 1 upon cos A plus sin A minus 1, and RHS they have given cosec A plus cot A. Okay, so now what is they have given is, we need to sort it out the further one. So how we can do it is, LHS side is cos A minus sin A plus 1 upon cos A plus sin A minus 1. Okay, so let us see how we can solve this. A very simple one. What we can do is divide both numerator and denominator by what we can do is divide by sine. So what you got, cos A upon sin A minus sin A upon sin A plus 1 upon sin A. Okay, here also cos A upon sin A plus sin A upon sin A minus 1 upon sin A. Cos A upon sin A is cot A minus 1 plus 1 upon sin A is cosec A. Okay, upon cot A plus 1 minus cosec A. Now we can write cot A plus cosec A. We can separate this. Okay, upon cot A minus cosec A plus 1. Now what we can write here using this identity, this one. Okay, so one is there. So what we can do is, take this cot square that side. So I got cot A plus cosec A minus this side. So you can write cosec square A minus cot square A upon this cot A minus cosec A plus 1. Okay. So now what we can do is cosec square minus cot square. A square minus B square. So I can write it A square minus B square. So I can write cosec A minus cot A or cosec A plus cot A. Okay. Now what is given below, we need to write similar one. Now we write cot A minus cosec A plus 1. Okay. So now we can take cot A plus cosec A common. Here I can write cot A plus cosec A, I have taken common. Left with 1 minus. So now we left with cosec A minus cot A. Okay. So we can write like this without using a flower bracket upon 1 minus 1. So we can write like this cot A minus cosec A plus 1. So here I can write cot A plus cosec A. So 1 minus 1 plus cosec A. Oh no, it will minus plus cot. Okay, I have just opened the bracket and outside the bracket is minus sign. So we will multiply with it. So we got this. So 1 minus cosec A plus cot A. Okay, so you can see this is same. So I got what? Cot A plus cosec A is equal to RHS. I hope it's clear now. It's a very easy numerical what they have given. Now we have solved 9 numericals. So I hope it's clear to you how we can apply these identities in such kind of numericals. So that's it for today. Thank you.